Hi guys, in this video we're going to be looking at the quadratic formula. Now in the other video we learned how to factor quadratics, and that's how we would solve for the zeros. Now not always will we have factoring available, so basically by that I mean not everything is factorable. So whenever something is not factorable, we are going to use the quadratic formula. The quadratic formula is right here. It's negative b plus or minus the square root of b squared minus 4ac over 2a. This formula will be provided for you on the formula chart, I believe, for the end of course for algebra. So you don't need to memorize it, you just need to know how to use it, I believe. Don't quote me on that. So let's go ahead and see what this all means. In example 1, we're going to solve the quadratic formula. So the first thing that we're going to do is label what ABC is. We've already learned how to find ABC because we used it when we factored trinomials. So A is 2, B is negative 1, and C is negative 15. Okay? Of course, my first step would always be to try and factor it. That's the easiest way to do it. Do factoring and then go from there. If it's not factorable, then I would try the quadratic formula. But for the hence of this video, purpose of this video, we're just going to do the quadratic formula. So the formula says negative b plus or minus square root, so on, so on. So let's start with negative b. b is already negative 1, so it's going to be negative 1. Plus or minus the square root, b is negative 1, so we put it in here, negative 1 squared, minus 4 times a is 2, so here's 4 times 2, times c, which is negative 15, so I plugged it in. On the bottom, it's 2 times a, so it's going to be 2 times my a, which is 2. And then I'm just going to do my math. So negative 1 squared, that I could actually just put this all on my calculator. I have to do it all. And I get 121. So negative 1 times a negative 1 is a positive 1. That's why we got a 1 here. So 1 plus or minus square root of 121, and 2 times 2 is 4. So those are my answers there. Now we can try and simplify this because we can get the square root of 121. We know the square root of 121 is 11. So we actually have 1 plus or minus 11 over 4. So let's spread that out into two parts. 1 plus 11 over 4 and 1 minus 11 over 4. So let's solve this one. 1 plus 11 is 12. 12 over 4 is 3. Okay, let's go ahead and try the other one. 1 minus 11, that's 10, and that's going to be 10 fourths, which is the same thing as 5 halves. So we could say 5 halves. Both of these are what we're going to do. So what did we get? Our final answer is 3 or 5 halves, which you could also write as 2.5. So the result is 2 real roots. Okay, let's go ahead and solve this. Now, there is certain cases where you will end up with what is called a double root, and you're going to see this in a second. I will also show you what it means on a graph. A double root is where it does this. It has only one real root, and it's shown as double because it's just that one vertex right there. So let's go ahead and try this. So we have r minus r squared plus 1. A is 1, b is negative 2, c is 1. We plug it into our formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b, that's negative, so that gave us negative 2 plus or minus the square root of b squared, so negative 2 squared minus 4 times a, which is 1, times c, and I'm sorry I'm running out of space, all over 2 times a, which is 1, which is what they wrote right here for us. Now again, we try to simplify, so let's go ahead and use our calculators. We know we can just plug in what's underneath the radical into our calculator, so negative 2 squared minus 4 times 1 times 1. So we get a total of 0. So we're left with just negative 1 times negative 1, which is 2 plus or minus 0 all over 2. Okay, so if we simplify this, that means it's 2 plus 0 over 2 or 2 minus 0 over 2. Well, both of these, if I was to simplify, give me 1. So we have one real root. It's called a double root. Why? Because it touches exactly, sorry, I drew that wrong. It would be right here at 1, and that just means it bounces up. So right there, this is that kind of problem where you end up with 1. Okay, now let's go ahead and look at this one. In this one, same thing. We're going to rewrite this into standard form. So we're going to add 7. So it's going to be q squared minus 4q plus 7 equals 0. Let's go ahead and write a is 1, b is negative 4, and c is 7. Okay, let's plug it into our formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So let's plug it in. Negative b, so negative 4 plus or minus the square root of b, so negative 4 squared minus 4 times a, which is 1, times c, which is 7, all over 2 times a, which is 2 times 1. Okay, so let's go ahead and simplify. Again, put everything underneath the radical first into your calculator. So that would be negative 4 squared minus 4 times 1 times 7, and that's a negative 12. So we're left with negative 1 times negative 4 is positive 4 plus or minus the square root of negative 12 over 2. Now, because we end up with a negative underneath the square root, this, since it's a negative, we're actually going to end up with an imaginary number. We don't cover imaginary numbers in Algebra 1. You will cover that in Algebra 2. Therefore, we're going to leave our answer like this. However, so like it says here, we learned how to handle square roots with a negative radicand. We're going to just state no real solution because there is no real solution. There is an imaginary solution, which you'll learn about later in Algebra 2. So if you end up with a negative underneath the square root, you're going to state that there is no real solution. Now the last thing we need to cover is how do we simplify radicals. So if you notice here, don't worry about the example. I just want you to include this in your notes. To simplify a radical, we take out what we can. We factor out that number into the prime numbers. So prime factorization, 2 times 25, so that 25 breaks down into 5 times 5. So basically we have the square root of 2 times 5 times 5. Well, I know that 5 times 5 is 25. I can get the square root of 25. The square root of 25 is 5. So I'm going to take this out. I'm actually going to break this down as to square root of 25 times the square root of 2. Square root of 25 is 5. I can't take the square root of 2. So to factor this, to simplify it, we get 5 square root of 2. And we'll go more over this in class, so don't think you have to get it right now. And that's it, guys.